I'm here to welcome you to this meeting, Global Change and Biosphere Interactions. And we're here to celebrate a number of things. The launch of the York Environmental Sustainability Institute, the British Ecological Society's centenary, and, as you can see from the banner, the 50 years of York University. I'm 50, I haven't got a banner. I think somebody missed their cue. Somebody was supposed to say, surely not a day over 27. So to the conference, why are we here? Of course, a serious purpose. And we have got a fantastic programme, and I think we'll have a lot of interesting, stimulating and enjoyable talks. But we have a serious purpose because, of course, ourselves and our planet are facing very serious challenges. And the conference is about understanding those challenges, and hopefully we're going to hear some of the latest research addressing them. And if I had to sum up the theme of the conference, it's really this: how can interdisciplinary research help us address the challenge of global environmental change? And of course, everybody here doesn't really need reminding of that challenge of global change, but I'm going to do it anyway. And John Beddington, of course, was somebody who encapsulated that very well when he talked about the perfect storm in 2030, when we need to produce 50% more food. We need to do that whilst water demand is going up and energy demand is going up even more. And we need to do all that in the face of climate change, rising CO2 levels, and all that means for rising temperatures and other climatic challenges. So I thought I'd start by just reviewing the sort of challenges that we've got and how we might address them, and link that to some of the talks we're going to hear over the 2 days. So I think the first challenge that some of us have found is actually getting the evidence that we need to understand what's going on, getting the right data at the right spatial and temporal scales. And Phil Einerson is going to talk to us tomorrow about some of the bottlenecks and barriers to establishing the scientific evidence base. And he's mentioned he's going to consign some people and procedures and processes to room 101, and he's already asked for a photo of me, so I'm quite worried already. And once we've got that data, we need to understand and model it and make predictions. And I've just given an example here of changes in sea ice and how the observations began to diverge from our initial models. And we're going to hear from Peter Cox quite shortly on how to predict the unpredictable, which sounds like a challenge in itself. Once we have our evidence, we then need to understand the impacts they're going to be on the natural world and how we might mitigate those and adapt to them. And we're going to hear from Jane Hill about conservation strategies to try and help biodiversity adapt to climatic change. And Georgina Mace this evening is going to tell us about the crucial role that biodiversity plays. And tomorrow we're going to hear from Dave Raffaelli about ecosystem services and how we might manage our land and sea resources more sustainably. But I think one of our biggest challenges is going to be preserving biodiversity in a time when we really need to increase our agricultural production. And food production is going to set us a number of challenges, I think. This is the prediction of the change in yield for crop production in 2050. And you can see for some places in the world, particularly those places that are causing most of the problem regarding climate change, there will be increases in yield, but for much of the world, where food production is already an issue, yield may further decline. One of the challenges is irrigation in the face of climate change. We already use a substantial part of the world's water resources for agriculture, so stretching those still further will be difficult. At the same time, our eating habits are changing. More of us want to eat horse beef, and that's producing challenges of its own. And in some parts of the world, raising any livestock may become particularly difficult. Ian Graham is going to talk to us tomorrow about some of the ways we can address these agricultural challenges. And perhaps our biggest challenge is the strain that some of these changes are going to put on our social and political systems. This is a graph of food price index over time, and as food prices rise, the number of political incidents, instability, riots, etc., and political breakdown, those incidents increase quite dramatically in times of high food prices. So there are going to be impacts on our political systems, and we're going to hear something about that from Adrian Ely. He'll talk about the challenges of implementing innovation. From Susan Owens, about policy and the policy implications and how we might form better links between science and policy. And I'm really looking forward to hearing from Mike Hume tomorrow about how our belief systems might need to change, our fundamental attitudes. And one group of people who perhaps will need to change their attitudes more than any other are politicians, which not always grasp the gravity of the situation, or indeed grasp anything very much. The soil goes at the bottom, George, for goodness sake. So we've got a lot of challenges and we're not addressing them terribly well sometimes. And the impacts of all these changes are going to span the disciplines. We're going to see impacts on the physical environment, we're going to see ecological impacts on species, and we're going to see social impacts on our political systems and on ourselves. So we're going to have to get interactions between the disciplines to solve some of these challenges. But impacts span timescales as well. And perhaps one discipline that we haven't focused enough on is looking back, looking at the past. What can we learn from the past? And we're going to hear from Mark Pagini very shortly, actually, looking at geological timescales and environmental change. And from Matthew Collins, the impact of those changes on us and how archaeology can help us understand those. So I think a full understanding of global environmental change, how we're going to mitigate its impacts and adapt to its effects, it's going to need a new way of thinking, a multidisciplinary approach which crosses traditional boundaries. And of course that's the rationale for YESI. That's why the University of York was very keen to set YESI up. We've got a number of aims. Particularly like to highlight that we're interested in generating the evidence base for sustainable solutions to environmental change. And this aim is one that's particularly close to my heart. I'd like YESI to foster equal partnerships between natural, physical and social sciences, because I think that's what's going to be essential for us to move forward. Plus the fact it's really interesting and exciting to do as well. So we're keen to facilitate interactions between departments and to develop new synergies between disciplines, particularly interested in collaboration in innovative ways. Now, you should all have had a little brochure about our research, so I'm not going to talk about that in any great length. I just wanted to highlight for you some projects that I think show the sort of approach that we've got. So, development of sustainable cities, and I'm going to tell you about a project in greenhouse gases and atmospheric processes, and lastly, food production resilient to climate change. What we're interested in terms of sustainable cities is the link between human behaviour and the built environment. And these projects involve a number of different researchers, particularly from the Centre for Housing Policy. And we have one project that's interested in the impact of the built environment on well-being of older people. So how do life transitions like losing your sight, losing a partner, going into care, interact with local infrastructure to affect mobility and human well-being? We've also got a project on sociological evaluation of housing, and it's based on a new housing project for the Joseph Rowntree Trust at a new development called Darwin Quote, and that's the sort of housing that's trying to lower energy use and promote community involvement. But to do that, of course, we need to understand how people respond to information about their energy use. So these projects involve biologists, health scientists and psychologists, physical scientists, computer scientists, and many, many different sorts of social scientists, transport economists and experts in planning, policy and GIS. Another very innovative team is a group of people working on a project called Sky Gas. This is led by Phil Einerson, and he's going to tell you about this tomorrow, so I won't steal his thunder, but just to highlight that this is the first cable-operated trace gas monitoring platform based on the kind of fly-by-wire camera sort of techniques. And this is a really novel way of trying to accurately assess global greenhouse gas fluxes from landscapes. And this brings together a team of atmospheric chemists, ecosystem ecologists, electronic engineers. So, again, a broad range of people. And the last project I wanted to tell you just a little bit about was a project we've got looking at how to make food production more resilient to climate change. This is led by Ian Graham from CNAP, and he'll be telling you a little bit more about that tomorrow. We're interested in working on rice, which is the primary food source for 50% of the world's population. But like many of our crops, it's been bred for high yield at the expense of other traits, particularly resilience to environmental stress, such as water shortages and pest resistance. But it may be that ancestral varieties of our crops retain better abilities to cope with those sorts of stresses. And the other important part of the equation is that 45% of the Indian rice crop, is rain-fed. So climatic change will make a big difference to yields. So in the face of that, we have a project under the Sustainable Crop Production Research for International Development, the world's worst acronym, SCRIPID, and even the BBSRC who dreamt it up admitted it wasn't one of their finer efforts. And our aim is to use genes from ancestral varieties and introduce those into elite cultivars. Now, this is what I call a rice plant. This is a Rhiza rufipogon, an ancestral variety, which is considerably beefier than our elite cultivars, although the yield is completely useless. So the idea is that you can take beneficial traits from this plant and introduce them into our high-yielding cultivars and hope to maintain those high-yield traits, but maintain them under environmental stress. So we're aiming for increased yield under drought. Now, of course, there's more to improving crops than just producing a new plant. We need to make sure that those crops reach their potential, and that will depend on socioeconomic factors rather than agronomic ones. So that'll be things like farmer take-up and really looking at how we might best improve the livelihoods of farmers and making sure the benefits get to where they need to be. So we have a large socio-economic component of this project as well. So it's bringing together climate modelers, crop geneticists, plant biochemists and physiologists and agronomists, but also social scientists. And I think this team approach, which is bringing together very diverse expertise in innovative collaborations to deliver the solutions we need to face the challenges of environmental change. That's what Yes is all about. That's the aim of our approach. And I think we've brought together a very interesting programme of speakers who I think can also show the sorts of ways that we can address these challenges. And I want to leave the last word with Darwin. Our planet is shrinking, really. The amount of land per capita is going down rapidly. And I think this quote from Darwin is one that is very pertinent. The species which survives is not the strongest, nor even the most intelligent. It's the one that adapts best to change. And we've certainly done an awful lot of adapting in the past, and we're going to have to do a lot more in the future. So I hope over the next 2 days we'll hear about some research relevant to those sorts of adaptations and meeting the challenges that we face. So I'm going to stop there and hand over in a moment to our morning speakers.